I know you haven't seen the answers yet. Did it feel like the problems went okay? Because you very well might have done them correctly, and I wasn't trying to say you did them incorrectly. I just know that there's gonna be a handful that you'll find you don't have the same answer as. Because it seemed like most everybody had the process down for doing FG prime plus GF prime. Now, quotient rule, you'll see is semi-close. The parts that what I want to point out is the top of the fraction. So the quotient rule is whenever you're trying to take the derivative of variable information divided by variable information. You can use the quotient rule. And it's just a formula, okay? But the formula here is written reversed from the product rule. And I kind of wish that the product rule would be shown like this, but it normally isn't. The product rule is normally shown as FG prime plus GF prime. And the reason I wish it would be shown like this, GF prime plus FG prime, is because that's similar to the top of the quotient rule. The quotient rule is going to be the harder of the two to memorize, just for whatever reason. So F has to be the top, G has to be the bottom. So this one's slightly different than product rule, because that one it didn't matter which was which. F has to be top, G bottom. The quotient rule will be GF prime minus FG prime. So this one, the order will matter because it's subtraction. And that's why I kind of wish the product rule would universally be taught like this with a plus. But on AP, they traditionally teach it the previous way as well. So we've got GF prime minus FG prime over G squared. Now, I think I called this a song yesterday. Did I say I was going to teach you the song? No? Okay, good. It's not really a song. It's almost like a leprechaun or one of the seven dwarfs or something, like when they I think they call them limericks. Is that right, music people? Isn't there music people in here? There's usually music people that are math and music. Limerick's not right? Isn't that like an Irish phrase? Wait, nobody here is in choir or anything? Huh. That's actually kind of shocking. Frequently math and music kind of go together because music's a lot about patterns. And so there's frequently people who are good at both. Not me, but other people. So the phrase that most people remember, it's just easier to remember for them, is low-D high minus high-D low over low-low. And swear to God, at the end of the year, you're going to see people mouthing this to themselves during the AP test. So low-D high minus high-D low over low-low. Low representing the bottom. D high, derivative of top. High, top, D low, derivative of bottom. Low low would mean the bottom squared. This phrase, for some reason, is much easier for most people to remember than the formula. But I'm a weird person. I've always just memorized formulas better. I'm not usually like an auditory person. So, low-D high minus high-D low over low-low. Like to me, I picture like the seven dwarfs, like skipping along with the song. That's why I call it a song or a limerick or something. But I'm sure it'd be more like a leprechaun, like singing this one by the pot gold. So this is what we're using to find the derivative of a fraction. Nonetheless. We're going to start off the exact same. So So that is the good thing about product rule and quotient rule. They are similar in how they're laid out. Different formulas, but they're similar in how they're laid out. Where at the beginning of the problem, we're still going to figure out the same information. We're going to find f, f prime, g, g prime. The main difference being that there's specific f and g. But I believe most people probably made f the first item anyway and g the second. Okay, so f has to be the top. 2x cubed plus 4x squared minus 7. G would be the bottom, x minus 5. Now, as we do more and more and more of the derivatives, you'll definitely get a lot more comfortable at doing like power rule in your head. I'm sure you're probably still at the point where you have to kind of like pause and think about things. You'll just get faster as we do more. So like this f prime would be 6x squared, 8x to the first, 0. X minus 5, the derivative of 1x would be 1. Derivative minus 5, nothing. So those would be our 4 parts. And I'm going to have to really struggle to try to fit this information all in here. Okay, so the derivative of g is going to follow the quotient rule. So low, x minus 5. D high, 6x squared plus 8x. Oh, I'm going to have to write it underneath. Minus high, D low, all over low low, which means squared. Now, quotient rule is absolutely going to be a lot of simplification. So we definitely have to FOIL out the top. The times one on the bottom, on the second one makes it easy at least. I'm probably going to have to kind of do this in my head because I don't have any room. You guys can at least write smaller. I can't. So what do we have? We have 6x cubed. We have 8x squared minus 30x squared. So minus 22x squared. Minus 40x. So that's the first one FOILed out. The second one, I'm going to distribute this minus sign. You're going to be doing that on every one of these quotient rules because it's a minus every time. So you will get absolutely used to distributing out the minus sign. So minus 2x cubed minus 4x squared plus 7, like the times 1 made it nice, all over x minus 5 squared. And we'll simplify the top together because I don't know if it's going to factor or not. 6x cubed minus 2x cubed will be 4x cubed. Minus 26x squared. Minus 40x plus 7 over x minus 5 squared. Okay, now the annoying thing is we frequently will have to check to see if it factors. Because if it factors, we're going to be able to reduce and make it smaller. And I know right away your first instinct is going to be like, I don't care if it would get smaller and reduce down. But we are going to be doing second derivatives soon. A second derivative means we would have to take the derivative of this. So if you ever can make something simpler, the smaller you want to. Can anybody tell me why I don't even need to try to factor this? Why I know x minus 5 won't go into it? because there's clues that tell us we don't even need to try to factor.
There's a 7 at the end of the numerator.
Perfect. The only way you can multiply to get 7 is 7 and 1. And no matter what, -5 is not going to be a factor that would fit that. So I don't know how to factor this off the top of my head. I'd probably have to do some type of division. But I know 5 isn't going to go into it because of the 7. So I don't even need to try to finish. This will be the final answer. So these aren't going to be terrible. They're just going to be really slow.
You don't need to simplify the bottom then.
Say it again.
You don't need to like foil the bottom if you see it like that.
Oh, right. You don't want to foil the bottom. I mean, you could. It's not wrong if you do. But like on a test, if you foil the bottom and then accidentally foil it wrong, you get that wrong. I mean, like, just leave it. Less work means less errors. Why don't you guys see if you can try the second one? I have a feeling the second one will simplify more at the end because of the e to the x. But see if you can try the second one. This one will also have to have an x -5 to be able to cancel. So because of this minus sign in the middle, the only time you can cancel is when it's multiplied on the whole top. Yeah. Demetrius, you got this one? Do you want to come up and write at least write the f prime, g prime?
If you told me like what the derivative for EX is,
That's the easiest one.
this is 0.
Nope. So you're saying you want some assistance on that part?
Yeah.
Call on somebody. They'll help you out. Derivative of e to the x is the golden question on the test.
Also on a test, if we write the g prime of x
Uh-huh.
and the answer,
Uh-huh.
is that okay? Or do we have to write it for every single part?
Oh,
Front of it?
you definitely need to write it on the first one.
The first and the last and the
Yes.
answer, is that okay?
First and last.
Okay.
Yep. Yeah, that's why it's the golden one. E to the x has its own derivative. Okay, nice. Oh, I forgot, we got the roller. I'm sure some of you guys are kind of partway through now. And to Andrew, I was hoping you could write the first line of the quotient rule.
Yeah.
Okay. I know it'll be tough to fit in there too. That's all right, keep going.
Okay.
Are you asking me or telling me?
I'm asking.
Oh, it's not right.
It's not.
No. You'll be mad when you realize why in a second, probably. But you are going to do the exact same thing that a ton of people will on a test. What do you forget? The bottom. You focus, all your energy is like focused on the top, and you're going to be so used to doing product rule, which is only similar to the top. It's really easy to forget the bottom. So that should be over x squared plus 1 squared. Okay? Justin, what is the other thing that what's wrong about the left-hand side of what he wrote? I mean, you were doing the problem correct. I'm not trying to make it sound like this is like butchered. It's not a big thing. That's why I'm just, I want to make sure you guys get used to the details. Are you talking about the bottom?
Notation.
Oh, did you say G prime? Oh, yeah, that'd be correct. So writing d dx is you saying you are going to take the derivative. So if you would have written, again, this is a super minor detail, but as the year progresses, you'll understand the difference. d dx is similar to a verb saying, I'm going to take the derivative. So if you wrote d dx up here, that'd be good. You can. Because you're saying, I'm going to take the derivative of that. Once you take the derivative, because the quotient rule is the derivative, then you would label it the derivative. So like the prime notation means that is the derivative. d dx is the notation saying I'm going to. Like that's what I'm currently doing. Okay. This particular problem, I can almost guarantee the way that it would be done is the e to the x would be factored out of both terms. Because both halves have e to the x being multiplied, like a lot of people would write it like that. Both halves have e to the x being multiplied. What would be left is x squared plus 1, in a parentheses if you want, minus 2x over x squared plus 1 squared. What about that? Is that factored?
Why is it x squared plus 1 and not x squared 1? Oh, just kidding, I wrote it down wrong.
Oh, okay, that'll definitely do it. Honestly, I would have 100% believed I wrote it down wrong too, so.
Well, at first you told me you just factored the x out, right?
Correct?
Okay.
That's what I did at first. I also recognize that there's more to do. This is x minus 1 squared. Now, it's not actually going to help us, but hey, I'm going to write it because it makes it simpler. And we frequently are going to be using the derivatives to find answers. So the simpler you can write a derivative, the easier it is for you to use. Are we okay how we can factor that? Because it didn't sound like many people thought we could. Number one, it's written in the wrong order. Like x squared minus 2x plus 1.
Yeah.
Did I lose a lot of you halfway through?
No.
You look very reserved and apprehensive on this problem.
Can you explain how you got to the last part?
From there,
Yeah.
this particular problem, most people would write it as x squared minus 2x plus 1.
Yeah.
And that could be factored into x minus 1, x minus 1.
Oh.
And so then instead of writing it twice, I would write it squared. Okay? Well, this would be the final answer. Like I said, quotient rule you're going to find is a lot of simplifying, and that's, and I don't want to sound like I'm putting anybody down. I don't know why, but a lot of kids will come, a lot of students will be in Calc and do the Calc part really well, like the quotient rule. And then they will forget how to do math and not remember how to simplify anything. It's like you guys tried to black out the last 3 years. And that may be the case. I don't know, maybe you had a bad experience. Especially if you had me for algebra. Okay, do you want me to do this one? Are we okay skipping this one to get to the trig one? I will do whatever you guys want. Okay. Say what?
We did the trig one.
Yeah, I wanted to do the trig one for sure. Okay, well, let's start the trig one. Should we do this together? Do you guys feel like you wanna try it on your own?
We tried.
Try it on your own. See if you can simplify it, because that's gonna be the goal on this one. Trig ones sometimes simplify like crazy down. Sometimes they don't, sometimes they do. I haven't done this one yet. We'll find out together. I gotta figure out how to make that smaller. Oh, that doesn't work. Alright. Yeah, I thought so, but it doesn't want me to drag anymore. I mean, like, I can't highlight. That's good enough. It's moved over. I want you guys to be able to try to fill in the blanks in between. That should be the final answer.
Flip it out your way, I suppose.
I was guessing most of you would be pretty good at filling in the first line. That's the calc part. Then the algebra part and pre-calc part. Simplifying.
Would one minus cosine squared, would that be sine? It's not in this problem, but it's.
Yes.
Okay.
Yeah, it's not in this problem. Yeah, you probably will get that eventually, I'm sure. And or sometimes you put that in place of sine squared to make the problem easier. It actually shouldn't be terribly difficult. There's really only one thing you have to be able to spot. I thought it was this class yesterday that brought it up and talked about it. Do you guys want me to put it up there? Yes? Okay. Time we get done? 06? Oh, all right. The next line should read cosine plus cosine squared. Because cosine times 1, cosine times cosine. And then negative sine squared, but being subtracted, would be plus sine squared. Cosine squared plus sine squared is what you're supposed to recognize as 1. That turns into 1. So then your numerator is cosine plus 1, which happens to be the factor on the bottom. So you would cancel one factor from the top and the bottom. And get this. Now, I believe the next page of your notes, isn't that where it wants you to like find all the trig ones? Yeah, we're not doing that. Well, one time, there's not a chance we have enough time. This section would take us like we could make this take a week if we wanted to. Basically, that page is how they came up with all the trig derivatives. So they knew sine's derivative was cosine, and cosine's derivative was negative sine. I don't know if I have enough room up here, but I'll try. Good enough. The derivative of sine. Oh God. Sometimes my brain and hands don't do the same. Derivative of sine is cosine. Derivative cosine, negative sine. Derivative of tangent is secant squared. These were the three that we like talked about, right? Okay? I can write tangent as sine over cosine. And then I could do the quotient rule on tangent, and when I simplify the quotient rule, it would turn into secant squared. Derivative of cotangent, I could do the same thing. I could write it as cosine over sine and do the quotient rule, and I would find out that my answer is negative cosecant squared. Derivative of secant. We can write it as 1 over cosine. We would get secant tan. Derivative of cosecant. We would get negative cosecant cotan. Now, I wanted to write all 6 to see if you recognize the pattern. Sine, cosine. Tangent, cotangent. Secant, cosecant. What's even better is their answers correspond. I'll ignore those are the easy ones. Secant squared. The co-version, its answer is cosecant squared with a negative. Secant's answer, secant tan, you basically just have to memorize that. I remember it only because secant's answer has secant. Okay, so secant's answer is secant tan. The co-version's answer is cosecant cotan, negative. So the co-derivatives are all negatives. The regulars are all positive. And if you can essentially memorize these 3, you'll know all 6. That's going to be my tip to helping this, at least. Just trying to memorize all 6, it sucks. There's nothing nice about it. But if you can at least memorize 3, and I feel like that one you barely even have to memorize because you kind of just like know it. Like it's easy enough, it's like your brain just remembers it. So memorizing tangent and secant is going to be kind of your goal. Now, you'll notice sine and cosine don't actually fit the same pattern, which is kind of weird, but it doesn't matter. These fit the pattern, and that's what's going to help you memorize them. Okay, so that's that whole next page. That's definitely why I didn't want to do it, because like, it just, to me, it's not going to help you memorize them. All it's going to do is show you where they came from, and I guess the only advantage of that is if you forget the derivative, you could do the quotient rule to find the derivative, I guess. I mean, nobody's gonna do that, but that would take forever on a test. Okay, so that's pretty much all we have time for today. I know there's more examples, there's more stuff. Like I said, we could do these notes for 4 days if we wanted to. Just examples. And I will do a little bit more with you tomorrow, because that's higher order derivatives at the very end. That's second derivatives, third derivatives. In physics yet, have you guys gotten to torque?
No.
Okay, torque is the third derivative. So we'll, yeah. First derivative is velocity, second is acceleration, third is torque. That's how they come up with that information. All right,